Okay, here's a circuit with 4 motor coils with induced generator coils wrapped around them and behind them, sharing the same ferrite core. And I wound the motor coils directionally to go towards the rotor magnet so there's more force against the magnet. And I wound the induced generator coils to go directionally in opposite direction away from the rotor magnet. Directionally means you wind your layer starting from the back all the way to the front. When you get to the front, bend the magnet wire 90 degrees, pull it straight back to the back. Now bend it 90 degrees again and wind the same direction. And when you get up to the front, do it again, bend it, pull it straight back. And when you get to the back, bend it again 90 degrees and wind the same direction. And that'll make the flux of the coil kind of come out more cannon-like effect and with more force. And I wound these cone-shaped motor coils inside of here. And you just do that by not going all the way to the back all the time. Just kind of stop here and then start it. Stop here, start it, you know. And so these are cone-shaped motor coils wound directionally inside of induced generator coil winds. I use 25 gauge wire. This just happened to be what I have here. And these generator coil winds are wound directionally away from the rotor magnet. And so for those, you start back here and you wind like this when you get here. Bend it 90 degrees, come back, etc., etc. And so you'll have 2 leads for the generator coils and then 2 leads for the motor coils. And here's the in. I labeled them in and out for the motor coils so you can trace the motor coil circuit. All coils are in series. And it comes in from the positive 4 to 18 volts DC. It comes into the coils first, the power supply, and then it switches on the low side when it's going to ground where you put the MOSFET. And so the drain of the MOSFET as the coils, as the power is leaving the coils, it goes to the drain of the MOSFET, and that's where you put your flyback steering diode, of course, just like in the other videos I showed, and that points right into the positive side of a capacitor. And up here I show that the other lead of the generator coils, not the ground lead is all common ground for all 4. The other one has a diode for this lead, a diode for this lead, and they all point right into the cap too. Same thing down here. Make sure you put the diode on the right lead. If you have it on the wrong lead, the cap won't fill up very well in voltage, but if you put it on the right lead, the cap really fills up fast in voltage. The flyback spike also comes through these induced generator coils because it keeps making the cap climb in voltage. You can see the spike is actually captured too, and you're capturing the spike twice more or less, and then you're also the normal way with the steering diode on the drain of the MOSFET. Okay, read all this stuff I wrote here, and the also this one's right hand rule. That means this one's left hand rule, the direction of the winds. Right hand rule, left hand rule, because you want to have these directional where they start on the back of the coil and then they go to the front, start on the back of the coil and go to the front. So you have to have the wind direction correct for these directional coils. And so this is not using the bucket brigade cap into cap thing, and it's not using the decoupled cap discharge only when it's decoupled. It's not doing that either. It's just filling a cap up and the load goes right across the cap, because when I was testing this, the pickup coils, when you short them out, it doesn't do a thing to the motor. doesn't lug anything. And so I think this might be a Lenz-free way to make generator coils, is you wrap them around the motor coil in directionally in opposite direction. Okay, so I'm putting a link in the description down below of this video where it says show more. And I have a web page with this so you can like study it, not have to look it on your computer screen, or you can print it out, or you can just watch it on a computer screen. And then I have a bunch of other videos about directional winds on this web page, and so I'm going to have a link to that web page below this video. So, okay, thanks for watching.